Hey, what's up? Welcome back. Patrick here from All Things Mathematics. I'm moving on to the next midterm question dealing with matrix algebra. So here we're given this matrix A, 2, -1, -2, and 4. We have to use row reduction to find the inverse of A, and then we have to use the inverse to solve this set of equations here, 2x minus y equals -9, then -2x plus 4y is equal to 12. And notice that we can basically break this down into matrices form. We could take the coefficients 2, -1, -2, and 4. We can multiply it by a variable matrix x and y. That's going to equal the constant matrix on the right side, -9 and 12. And then notice that this matrix and this matrix are the same, right? So that's why they're saying use the inverse to solve for it, but we will get to that in part B. I'll elaborate on that further, but just wanted to show you how basically this matrix are the same, right? So we're going to be using what we find in part A in order to help us solve the equation for x and y in part B. So in part A, what we're going to do is we are going to find the inverse of this. So how do we do that? Well, let's set this up. And actually what I'm going to do, yeah, let's just leave it. Let's just leave it like this for now. It's fine. And then what I'm going to do is put the identity matrix on the other side like that. And what we have to do is try to convert this to the identity matrix. We convert this to the identity matrix, and then whatever matrix we end up with here, that's going to end up being the inverse right there. So what can we do? Well, first thing I think I'm going to do is I'm noticing that this -2, +2, well, since we know we have to try to get a 0 here, it's very easy to just say that our new R2 is going to equal our old R2 plus R1. Okay, I know this is not a 1 here. We want to get this as a 1. I'm going to do that a little bit later because I'm seeing a nice opportunity to make this a 0 right away. So I'm going to take it. And by the way, there's different ways that you may go about it in terms of row reducing this to get the identity matrix. So you could pause the video, try it on your own. Just make sure that the inverse that you get in the end is going to be the same as mine. Okay, so the first row is going to stay the same. And then what's going to happen, -2 + 2, that's going to be 0. 4 plus -1 is going to be 3. 0 plus 1 is 1, and then 1 plus 0, that stays as 1, like that. And then from here, again, different ways we could do it. We could divide everything by 2 because we know this is going to be a 1. But before doing that, what I'm going to do is I'm going to actually turn this to be a 0, right? We want that to be a 0. So how can we make that? How can we make an operation in terms of row 2 to make this -1 be a 0? So the new row 1 is going to be basically the old row 1 plus, I'm going to write a plus here because these are opposite signs. What do we have to multiply this by, this 3? We have to multiply it by 1/3, right? Because if we multiply it by 1/3, we'll end up with a 1. And then we could just add 1 to the -1 and then make that a 0. So what I'm going to say here is going to be R1 plus 1/3 of R2, like that. Okay, so what's going to happen? 2 plus 1/3 times 0, that's just going to end up being 2. That's going to stay as 2. -1 plus 1/3 of 3, as we mentioned just now, that's going to end up being a 0. 1 plus 1/3 times 1 is going to end up being 4/3, like that. And then 0 plus 1/3 times 1, that's going to end up being 1/3 right here. Then we're going to have 0, 3, 1, and 1 like that. And then from here, we got to change this 2 to be a 1. So what we're going to do is we're going to take the first row, divide everything by 2, and then I need this 3 to become a 1. So I'm going to take the second row and divide it by 3. like that. And that's going to give us our final inverse. Now you could have done this earlier in the steps, right? Turn this into a 1, but then there would be more fractions roaming around. Not that it's wrong, it's just personally, sometimes I leave that to the last step. Okay, so again, as I mentioned, different ways to do it, but whichever way you would have done it, what you should end up with, the inverse here, is going to be, okay, 4 over 3 divided by 2 is what? 2 over 3, 1 over 6, and then 1 divided by 3 is 1 over 3, and then 1 over 3. Like that. So that right there ends up being the inverse. Let's write it on the side here. So A inverse, the answer to part A is 2 over 3, 1 over 3, 1 over 6, 1 over 3, like that. Now for part B, how are we going to use this inverse here to solve this system of equations? Well, I set up the matrix form earlier like this, right? I broke down this system, this algebraic form, into this matrix form. And notice that this matrix here ended up being the A, right? And so what we can say is, I'm going to let this whole matrix be A. I'm going to allow this variable matrix to be M, and then I'll let this constant matrix of -9 and 12 be C. So what we could say is A times M is equal to the constant matrix C, like that. And what we want to try to do is isolate for M, right? We're trying to isolate for X and Y, or solve for X and Y. So how can we get this M value by itself using matrix algebra here? Well, we got to get this A value over. How do we do that? Multiply this side by the inverse, multiply this side by the inverse. Because the inverse times the matrix, that just gives us the identity matrix, right? And then the identity matrix times this variable matrix M, which is XY, that's just going to end up being XY again, right? The identity matrix times M is now going to equal the inverse of A times C, and then identity matrix 1, 0, 0, 1, which is the product of the inverse times the matrix, times the matrix M, X, Y. Well, if you do this multiplication, 2 by 2, this is a 2 by 1, so we'd end up with a 2 by 1 matrix again, and it's just going to end up being XY, like that. So basically, the identity matrix times M is just equal to the matrix M, and that's going to be the inverse of A times the constant matrix C right here. So basically XY, the matrix M, is going to be the inverse of A, which is what we found, so that's where the inverse is coming in, 2 over 3 times 1 over 3, 1 over 6, 1 over 3, times the constant matrix -9 and 12, like that. Okay, and so when we do this multiplication, again, as I mentioned, we're going to end up with a 2 by 1 matrix, right? Because this is a 2 by 2 multiplied by 2 by 1. The 2's cancel out. We end up with a 2 by 1, which is expected, right? That X and Y is a 2 by 1 matrix. So what would we do? First row times this column. 2 over 3 times -9 is -6, plus 1 over 6 times 12 is 2. -6 plus 2 gives us -4. And then 1 over 3 times -9 is -3, plus 4. That gives us 1, like that. So the X and the Y value is -4 and 1, respectively, right? X is -4, Y is 1. Now, those are our solutions, and we use the inverse to get those. And then you could test these, right? So if we plug it in, 2 times -4 is -8, minus the Y value of 1 does indeed give us -9. And then -2 times -4 plus 4 times 1, 8 plus 4 is indeed 12. So notice that both of those values do satisfy those two equations, and that ends up being the final answer to this question.
And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.